All right. On this video, we're going to be talking about dividing polynomials using long division. So the first thing we're going to review, we're going to go ahead and recap some concepts with long division where we don't have a remainder. So we're going to first talk about the area model, and then we're going to talk about using long division, which is like our normal long division with polynomials. So I have my area model. I'm going to do a 2 by 2 area, and I'm going to put my bottom this term that's on the bottom, or rather this polynomial that's on the bottom, that is the factor that we know. We know this factor. We've been talking about multiplying two factors together and finding the area. Okay. We know one of the two factors and we know the product of those two factors. Okay. That's the value, the polynomial that's on top. We're going to put the factor that we know on the side here. So I'm going to put x, and then I'm going to put plus 3. And I'm also going to put the first term of the area that we know for sure. Um, that's going to be 3x squared. I'm also going to put the relationship that we know in regards to the middle term. So I know that these two terms right here are going to add up to 8x. Okay, now technically you might want to just go ahead and say the last box area is -3, but I don't want to talk about that just yet because, and you don't want to necessarily get in the habit of doing that because just like in today, this is possibly a remainder, in which case those two values will not match. All right, so we're going to go ahead and work through our problem here. So I know the area of this box, this rectangle, and I know the length of that box. So I'm going to use the relationship that I know of area with the relationship to the side. So we're going to divide. We know the area, the product is 3x squared. We're going to divide that length that we know, which is x. We know using exponent rules, we're going to subtract the exponents, considering that there's an x to the value of 1. And the bottom, if we don't have an exponent there, it's 1. We're going to subtract the exponents. 2 minus 1 gives me 1. So this becomes 3x. So we know our width of this side is going to be 3x. So we know that 3x times x is going to give me that area of 3x squared. Now we can find the next value. 3 times 3 is going to give us positive 9. And we can't forget the x. We also know that this area over here is also going to have an x. Now I'm going to use the relationship that I know between what those two are supposed to add up to and what we know. So I'm going to take what we know it's going to be equal to, which is 8x, and I'm going to subtract that known information, 9x, and that's going to give me the value that we need, which is -1x. Okay, now that we know that value, now we know the area of that box, just like we did the first box. I can now find the length of the box. We know the width is x, so -1/2 x divided by x is going to give me -1. Now we know the other factor. The other factor is going to be 3x minus 1. But let's go ahead and finish out our area model. So now we're going to do -1 times 3, which is going to give me -3. That does match, so we know we have a 0 remainder. And to remind you, when we get to the part of where we write our answer is going to be what the quotient is, which is 3x minus 1. And we're done with using the area model. Now let's go ahead and use the long division version. And as you see, it will match exactly what we have in the area model. So I'm not going to be looking at, I'm not looking at x plus 3 going into 3x squared. I need to look at, because I have two terms in the divisor, I need to look at two terms in our polynomial. So I need to look at the 3x squared plus 8x. X plus 3 will go into those two terms. Now, in terms of figuring out how to take the difference or what I need to subtract, I need to take a drink. I'm going to look at the first term, 3x squared, and the number that is being divided into, and our divisor. So I'm going to do just like we did in our area model. I'm going to take that 3x squared and divide it by x. So 3x squared divided by x, that's going to give me the 3x. Now, just like a normal tens place and how we do long division and normally, I want to line it up correctly. That 3x is not going to go into the 3x squared. It's going to go with the relationship to 8x. So I'm going to line it up on top of the 8x. Now we're going to multiply. So the first thing you're going to do is divide. Now we're going to multiply. Remember, you have two terms in your divisor. So 3x times x is going to give me that 3x squared. 3x times 3 is going to give me that 9x. Now, just like we did over here, these terms right here are those same values right there. And if you look here, so we're going to subtract. You know you have to subtract the number that you created from the previous value. These zero out, and that becomes 8 minus 9. Look over here what we did. We had 8 minus 9 to find that unknown value on terms of this area of this box. We're doing that right here. So I'm going to do 8 minus 9, which is going to give me that negative x. We're going to subtract that, like which we did, blah, blah, which we just did. Then I'm going to bring down, we're going to bring down that negative 3. Again, look right here. That is the same values right there. Okay. Now we're going to multiply, or we're going to go back. We're going to divide. We're going to divide this term, negative 8x, with 8, which is going to give me negative 1. We're going to multiply. Negative 1 times x gives me negative x. Negative 1 times 3 gives me negative 3. When we subtract this, we want to make sure that that changes the signs, and we have a 0 remainder. So that's a recap on dividing polynomials with two approaches. Now, we're going to look at the long division and the area model. We're going to look in the, now these do have a remainder. We're going to go ahead and look at the long division first because I want you to see that in some ways it's easier to identify the remainder when you're doing long division versus an area model. All right, so just like we did the previous model, we're going to divide first. So I want to take the 2x squared, and we're going to divide that by the first term in our binomial, which is x. That's going to give me 2x. Now, we're going to multiply. I'm going to do 2x times x, which gives me 2x squared. 2x times 5, which gives me 10x. We're going to subtract minus minus. That zeroes out. That gives me positive 1x. We're going to bring down the 11. That's plus 11. Now, we're only looking at the first term on both polynomials. So we're going to divide. X divided by x is 1. So 1 times x is x. 1 times 5 is 5. Now, we're going to subtract. As you notice here, this is the first time that these two numbers do not match. So that's 11 minus 5, which is going to give me 6. So we have a remainder of 6. Now, let's talk about how we write our answer. I'm going to go and talk about a quick side, and I'm going to talk about saying like 7 into 10. Okay. 10 is divided by 7 one time. So this becomes 1 times 7, which gives me 7. And we're going to subtract 7 from 10. That's going to give me 3. So 3 is our remainder. Now, there's a couple ways that we write our answer in terms of 10 divided by 7. We can write this as 7. Oh, not 7. We can write this as 1.3. Or we can write this as a mixed fraction. So how I would write this as a mixed fraction is 10 divided by 7 is going to be equal to our quotient, which is going to be 1, our remainder over our divisor. So again, that's the mixed fraction. And think about how you turn that mixed fraction into a whole fraction. You want to multiply and then add the number up top. So that would be 1 times 7. 1 times 7 would be 7, and then add the 3, which would give you the 10 that's up top on the original quotient. And that's how we represent our remainder, or a way to represent our remainder when we're dividing. So we're going to do a similar thing with the long division polynomial. So I'm going to write our quotient. So that's going to be 2x plus 1. Then since this is plus 6, I'm going to go ahead and put plus, and then I'm going to put a fraction, and then I'm going to put our divisor. Just like over here, we put the set 3 over 7. I'm going to put our divisor. So our divisor is the x plus 5. And then I'm going to put our remainder on top. And that's how you would represent the remainder as a quotient using long division and polynomials. So that's basically that mixed fraction concept that we originally did. Now let's go ahead and talk about the area model. And of course, once either way that works for you, absolutely do either one that works. All right, so I'm going to do my area model just like before. I'm going to put my factor that we know on the side here. And then I'm going to put the area that we know over here. We know that that's going to be 2x on top. So I'm going to go through this part a little bit faster just because we know some of the values here. We know that this is going to be 10x. So again, there's that 10x relationship that we had when we did the first dividing. We know that these two are going to add up to our middle term, which is 11x. So we know that that's going to be plus 1. So this needs to be 1, plus 1x. Then 1 times 5 to find that last area, which is going to give me that area of 5. So here's where it differs. So you know you have a remainder because these do not match, okay? So the 11 and the 5 don't match. Well, think about what we did over here. We did 11 minus 5. So we did that last term, and then we subtracted that multiplication area value. So we did 11 minus 5, and that gave us that remainder. So I'm going to do the same thing here. I'm going to take that last term, or it's called the C term. We'll go more in detail a little bit later, but that last term in this trinomial is called the C term. And we're going to take that C term and we're going to subtract 5 from that C term, which gives us the 6. Okay, so now we know our remainder is 6. And of course, just like before,